since 96, when I fixed the rewrite rule system, which also means that I have been using and hacking Postgres for 2 years earlier than that. I also implemented several features that are still recognizable in Postgres. I don't want to go over them in detail, but there's one thing that sticks out, and that is Floaty1. Floaty1 is a database replication system. It was first for Postgres, which was based on C-level language triggers and had a origin multiple subscriber with cascading architecture. The implementation is totally outdated. So I would not want to expand this into a multi-active / multi-master system, but it is still used today after 20 years. It was released in 2004. So it's still there. Now, the features are interesting because you had controlled switchover, failover that inherited all surviving nodes, those features. And these are features that still are not in logical replication info, which is, to me, a catastrophe. Yeah, how the developers or designers of logical replication could have missed those features in the early design, I don't understand it. But if we want to have something that does this, it needs to solve the problem that we cannot solve today. So why do we need pgEdge? This is because if you have a distributed system, globally distributed or distributed far enough so that the speed of light becomes a real pain to you, then you will have latency in the system. One way or another, either the faraway client, the end user, accesses a faraway application that is close to the database, or you distribute the application. Don't do it. That's a bad idea. I've seen it. And then the remote application has the latency to the database. Nothing is good. So the common problem here is the central database. So we need to distribute the database. Put the data closer to where it is needed. Yeah. We, of course, today need to do it in logical replication. There's no other way. Physically, we will not be doing it. Because we want to be multi-active. All the database need to be writable. We need to have cross Postgres version. We need to be selective on several levels for table, by row level, filtering, and so on. So that dictates logical replication. Also, we want to only propagate the changes, not the whole wall. Bulk operations like reindexing and whatever vacuum is doing, or compacting tables, packing, repack, that should never be replicated. Yeah, we want to have one extra bonus out of it: near zero downtime, major version upgrade. All right. There have been attempts to do this in the past. One of them is pgLogical and BDR. Unfortunately, the developers of pgLogical and BDR basically stopped feature development after pgLogical 2. And pgLogical 3 and everything after that was taken proprietary as a commercial product. Source code is not available. And I know how the Postgres community feels about that if you don't make the source code available. It's not right. And so I don't want to talk about that too much. We know what it is. So we took pgLogical, the last version basically, and made it into Spock. So Spock is purely based on pgLogical, but we reactivated the pieces that were attempted to become multi-master with BDR. We enhanced them with what I call conflict-free delta apply. In the literature, it's called coordination-free. So if you want to look up for the concepts that are behind conflict-free, it is called coordination-free. It's just a term that does not sit with me. It doesn't tell me anything. We, of course, want to have better management functionality and better stats for monitoring the system. And we want to support partitioning in many different ways. There are many reasons why you want to support partitioning in different ways. One of them is, for example, there is legislation underway in the European Union that will make it illegal to share personal identifiable information and other stuff with countries like the United States, where people's rights are so protected that Europe says, no, you can't have our data or the data of our citizens. Anyhow, we want to make that configuration so that you don't have to do it in the application, that you configure it in the database. Yeah? Now, about conflict resolution, I don't think I have to talk too much about this slide with this audience. Who here does not know what last of a win? All right, slide down. Yeah, I don't have much time. About the conflict avoidance, that's much more important. So, logical multi-actor replication can really get screwed up with conflicts if the database is not told what actually happened. It depends on the business process, what really needs to be replicated. And last of the wins is not the right answer for things that are inventory counters, account balances, and that kind of thing. Yeah. Now, there are standard approaches to this. They are called conflict-free replicated data types, short CRDT. We took a different route. Instead, we tweaked Postgres itself so that it can support the standard Postgres data types, like numeric and integers, and do the right thing without the application knowing. So to give you an example, okay, there is a small patch. I want to get it into Postgres core. It's not there yet. It adds one option to the alter table column set infrastructure that is already there in standard Postgres. And that is more old value. When that is set to true, the heap IO is forced to log the old values of those columns that are marked this way. And that way, I can do what conflict-free replicated data types are doing, which is, since I now have, on the receiver side, the old and new value of the transaction's origin available, I can let the apply worker calculate a new value as the old local value plus the delta that has happened on the transaction's origin. And that gets me to the right answer. Because if we look at an example, this will always create a replication conflict, doing it in this time section. So on node 1, I update the balance column from 300 to 310. But since it's a balance type column, it's in reality, the business process behind it is at 10. This query doesn't tell me that. Yeah? On the node 2, I do the same thing in principle. I add 5. So the correct answer is either 310 nor 305. It's the sum of the old value plus all the deltas. And with the above shown logic, I end up at 315 correctly over time. This is what we call effectual consistency, because until everything is replicated out left and right, they will eventually show the intermediate balance of 310 and 305. But once the traffic quiets down, everything levels out at 315. What's currently critical in our to-do list is we can handle intermittent network outages or node outages. You know, you have to restart a node, it crashed, or you have network partitioning. We can handle that very nicely. It works super robust. What I can't do at this moment, and I'm designing that, is recovering from a catastrophic failure. If the data center is pancaked after an earthquake, you're not bringing that data server back online, at least not soon. And so I can't recover from that at this moment. It will be solved by Q3 or Q4. Promised. And then, of course, spinning up complete replacement nodes. That should be that. I'm working on that. I have something working. It's not 100% outage free, but it's coming. We're getting there. So there's a lot of to do still. What you can find online, the code does not have these capabilities today, but they are coming. So we have two major products, basically. One is pgEdge platform, and that is all the features of Spock itself, plus command line interfaces that let you control all of that functionality. Spin up a node, install Spock, and basically the whole deployment part. The pgEdge node control command, which is outside of Spock, is the one that's controlling it. I'm not going to give you the man page for this now. I'm not going to read it to you, but that is basically your control interface. And that means that the key values of Spock and pgEdge platform is low latency, because the data is now where it's needed, local. As soon as I fix the catastrophic node failure problem, we will have ultra-high availability. And we have data rate readiness, because with selective table and row-level filtering and partitioning, I can replicate a single partition or the whole partition table. With that, that allows me to make sure that certain data stays in a certain country. Talking about licenses, we know that the community is very edgy about licensing. So I will only say this, pgEdge is aware of that. We have a community license that is pretty much identical to the Confluent community license, which is do with it what you need, put it in production, however much you need it. The only thing that you can't do is turn this code around and make it into a competing business. It competes with us, with our service, which I will explain next, which is pgEdge Cloud. That is our managed database as a service offering. It is controlled by a UI, a dashboard, a whole web UI that does all the provisioning for you and so on, and monitoring. And it can do all that across different cloud vendors. So if you need to branch out into a region where you say, I don't want to have Azure there. I want to have Amazon Web Service there. Or whatever, you don't want to go with your standard cloud provider. We can do this with Spock across different cloud providers. Yeah. And the UI harmonizes the access to everything because we do the provisioning behind the scenes. This whole set of slides is about an outdated version of the UI, so I will not talk much about it. That charming young lady up front, Katie, can give you a demo of that UI right there live at our table to the right. So I'm not wasting time on that. About security, we basically expect you to bring your own account for your cloud provider, but then do all the peering, creation of the global networks, and it's all done in best practices for the usual cloud access. I'm not the expert on that. I can't tell you much. If you have specific questions about the security infrastructure, come to me. I will take them. I will forward them and get back to you with the answer. Okay? So, in summary, we aim for low latency, ultra high availability, data residency, optimizing for the network edge to really put the data where it is needed, fast. And if you so choose and don't want to go with the pgEdge platform and do it all yourself, we offer you fully managed database as a service with the web dashboard and APIs